In this lesson, we're going to start talking about the concept of functions. And as you get to higher math, we deal a little bit less with equations and a little bit more with functions. So basically, let's just talk about the way to write a function with functional notation. An equation that you might be familiar with is, for example, y equals 2x plus 3. Again, that's the equation of a line in slope-intercept form. We know it's a linear equation because x is to the first power. However, there's certain parts of this equation that are important. For example, there's two variables here, and one is your x is your independent variable, okay, and y is your dependent variable. And basically what we're saying in this problem is that the value of y depends on x. So every time x changes, every time you change your independent variable or the value of it, or you change your input, your dependent variable or your output will change in relation to that. And so when we have the combination of x, y, we're sort of thinking of x is our input value and y is our output value. That's one way to think about it. We also can think of it as x is the independent variable and y is the dependent variable, okay? And so, again, all of these are sort of understanding that the value of y is dependent upon x. Well, a little bit more clear description or way that I can represent that is by saying, I can put it in functional notation saying f of x equals 2x plus 3. And so you might say, well, what does that mean? Well, notice it's just replacing the y. I'm not really doing anything. It's not like it's f times x. It's read f of x. And basically it's saying that the function of x the value of the function when at x is 2x plus 3. And anytime that I change x, so the value of the function if x is 1 would just be 2 times 1 plus 3. In other words, whatever's here, I'm going to put it in there. I'm going to substitute it in. So in other words, when x is 1, when my input is 1, my output is 2 plus 1 or 2 plus 3 or 5. So that ordered pair, 1 is my input, 5 is my output. And I can write it in functional notation, like the value of the function when x is 1 is 5, or I can write it as an ordered pair. Same thing as if I had just come over to here and said, hey, what's the value of this equation if x is 1? Well, you would have said, oh, the value of the equation is y is 5. When x is 1, y is 5. So f of x is really a fancy way of writing it, of writing y. But what's interesting is that when you do have f of x, it is a function, you know a couple of things. Number one, it really makes it clear that the value of the whole thing is dependent upon whatever x is. And that's important to note. The second thing is that when you know something is a function, you know that for every x value, there is only one y value that matches it, okay? You can't have multiple y's for the same x. So let me show you what that might mean. So first of all, is something a function? We'll get into writing the functional equation. However, let's think about this. Notice that here I have 1, 2, negative 2, 4, and 3, negative 1. Well, notice that each of these is its own x value. No x value is repeated. Each one has its own y value. So yes, this is a function. In the second one, though, note that 3 of these have a repeated x, right? When x is 1 here, y is 1. When x is 1 in the second one, y equals 2. And when x is 1 here, y is 3. So when the same x value has 3 different y values, so this would not be a function, okay? Let's look at this other way of writing it. Notice that when x is 1, y is 2. When x is negative 1, y is 4, and when x is 3, y is 1. So yes, this is a function. Each x has a unique y. Now we go to number 4 and we note, okay, when x is 4, y is 1. That works. But notice here, when x is 2, we have 2 y values for it. So it's negative 2, 1 and negative 2, 0. So Negative 2 has two different y values, and so this is not a function. Now, there's a easier way to tell if it's a drawing. It's going to be in the next slide. But there is an easier way to tell. If I was to draw this out, obviously when I give you ordered pairs and stuff, you kind of got to think about it. However, if I plot these on the graph, you know, then you can really identify, like for example, in number 1, it would be 1 and 2 here. It would be negative 2 and 4 here. And it would be 3 and negative 1 here. Notice that none of those points, no x has the same y, right? So that one's kind of easy. If I go to the second one, when I draw it out and I get 1, 1, I get 1, 2, and I get 1, 3, and then this is 2, 3. Again, notice that this x value of 1 has 3 different points that are represented there. And then, so there's a trick to this too. It says, hey, if you can take a vertical line, if you can just draw a straight line down on a graph, and if you only hit one point when you do that vertical line, then it's a function. If you hit multiple points, it's not a function. So let's say I just give you some general graphs here, right? Let's say that I, draw a graph here. I draw a parabola, right? A traditional quadratic parabola. Well, when I do my straight line test, notice that I only hit each time in one point. So guess what? A quadratic equation where it's x squared is definitely a function. Now, what if I drew one that looked like this? Well, if I go down, I notice, oops, look, I hit 2 points in one with one vertical line. So because I hit 2 spots, this is not a function, okay? So a vertical line test is one great way to tell if you have it in a graph form. So again, in a graph, if a vertical line intersects the graph at more than one point, the graph is not a function. If the other way to tell is if the y is raised to an even power. So there's from an equation, okay? If you happen to have a y that is squared, or y to the 4th, or y to the 6th, etc., an even power, it is not going to be a function, okay? However, if y is raised to the 1st power, or the 3rd power, or the 5th power, or any other odd power, then yes, it's going to be a function. These look like this on a graph. And when you do your vertical line test, you end up hitting it in 2 spots, or similar to that. The other ones, like y to the 1st power, I'll show you that one later. Y to the 3rd, again, looks something like that, or you might even have like that. Y to the 5th is similar. But again, it's always going to end up being a function. So when it says here, determine whether y is a function of x, right? Again, x squared is a quadratic based on the x. Yeah, that could be a function. X to the 1st power, again, yes, that could be a function. So what's really going to matter here is not the exponent that goes with the x, okay? The issue is the exponent that goes with the y. So here, y is to the 1st power. It's odd, so yes, this is a function. Here, y is squared. It's even, so no, it's not a function. Here, y squared, nope, not a function. This is actually the equation of a circle, if you remember that from algebra. And again, if you go down and you hit it in 2 spots, it's not going to be a function. And then the last one, again, y is to the 1st power here, even though you don't see it. And so, yes, it's a function. So once we know it's a function, we could change it to function notation, and we can talk about some additional things. So f of x represents a function. So automatically I know that for every single x value that I put into this function, I'm going to get one unique y value that goes with it. So if it says find f of a, then what happens is you're going to basically take this variable, and wherever that variable shows up in the equation, you're going to replace it with a, okay? So I'll show you some examples coming up. So again here, notice you've got two functions here, and functions are given letters to represent them. Like, so the name of this function is f. So function f, the value of the function f, right, is going to be represented by this equation, x squared plus 3x plus 1. This function here, function g, is going to be represented by this equation. So first thing is, again, it could be f, g, h. The letter in the front is irrelevant. So when it says f of 0, what this is saying is, what is the value of the f function when x is 0? So you know that the equation is x squared plus 3x plus 1, and so you're just going to plug 0 in everywhere where you see an x. And so cancel, cancel, and you end up getting 1. So the value of the function when x is 0 is 1. You can write it like this, or you can write it as an ordered pair. When x is, an input is 0, the output is 1. Okay? What is the value of the f function when x is 1? So again, you're going to do 1 squared plus 3 times 1 plus 1. So 1 plus 3 plus 1, and it's going to equal 5. So the value of the function when x is 1 is 5, or you can write it as an ordered pair 1, 5. Negative 1. So again, you remember your order of operations and all that, but you're going to do negative 1 squared plus 3 times negative 1 plus 1. Again, negative 1 squared is 1. 3 times negative 1 is minus 3. And you're going to end up getting minus 1. Or here, I'll just do minus 1 there. So I know the value of my function when x is negative 1 is negative 1. Or I can write it as an ordered pair with input and output. Now notice the next one says g of 2. So that basically what we're using here is we're using the formula, or the equation rather, for function g. So we want to know when x is 2, what happens. And again, be careful, you're not squaring the negative, you're only squaring the x. So I always put parentheses in what I plug in. So I get the opposite of 2 squared, which is 4, plus 8 plus 1, so minus 4 plus 9, and it equals 5. So I know that my g of 2 equals 5, or 2 comma 5 as an ordered pair. Okay? Now it gets tricky when we have you insert expressions or variables, but again, the same rules apply. So remember, you're doing the opposite of x squared. So if x is t, that's what I'm going to plug in, plus 4 times x, which is now t, plus 1. So it's going to be minus t squared plus 4t plus 1. And there's my answer. So the value of the function when x is t is going to be this expression. And so there, I'm not going to put that one as an ordered pair, even though I could. You know, if my input is t, my output is minus t squared plus 4t plus 1. And that is an ordered pair, believe it or not. However, this is the way we would write that one. And again here, notice the value of the function when we have x plus 2, right? Instead, so I know again that my equation is going to be the opposite of, now I'm going to insert this expression here for x. Then it's 4 times that same expression plus 1. So here I have this minus, and yes, I have to take x plus 2 and square it, so I've got to FOIL it. It's going to be x squared plus 4x plus 4. And then I'm going to distribute this 4 plus 4x plus 8 plus 1. So notice this negative out here, I've got to distribute this negative here. So I'm going to expand this out to minus x squared minus 4x minus 4 plus 4x plus, and I'll add 8 and 1 and make it 9. Now minus 4x and plus 4x will cancel. So I'll get minus x squared, and then the minus 4 and the plus 5 or plus 9 will be plus 5. And so the value of the function when x is x plus 2 is going to be this answer, negative x squared plus 5. And that's really the solution. So again, it's just about plugging these values in for x. Now it says here, evaluate the function given that h of x equals 10 minus 3x squared. So again here, now they're dealing with a function called h. So they want to know what is the value of this function when x is 2. So again, I'll write the original function down and then I'll sub in a 2 for x. So it's 10 minus 3 times 4. So it's 10 minus 12, and it's negative 2. So again, the value of the function when x is 2 is negative 2, or you can do 2 negative 2 that way. And again, check your order of operations. Remember, the only thing squared is x. You have to square this first, then you multiply it by 3, then you do your subtraction. So again, here I've got what is the value of the function h when x is negative 2. So 10 minus 3 times negative 2 squared. So that's 10 minus 3 times 4. And again, that's 10 minus 12 or negative 2. So guess what? When the function, when x is negative 2, the value of the function is negative 2. So it's negative 2, negative 2. Okay? And the last one, I'll make it when the function, what is the value of function h when x is x minus 1. So it's going to be 10 minus 3 times, and then instead of x squared, it's going to be x minus 1 squared. So again, it's going to be 10 minus 3, x minus 1 squared. I have to do this first, so x squared minus 2x plus 1. Then distribute that minus 3, 10 minus 3x squared plus 6x minus 3. Combine my like terms here. This is good. Plus 6x is fine. And then 10 and negative 3 is 7. So the value of the function when x is x minus 1 is going to be negative 3x squared plus 6x plus 7. Now here we have what we call a piecewise function, and we did a little bit of this, and I'm sure you covered it in Algebra 1 a little bit in a graph where you were given a graph and, you had kind of like different parts to the graph. Like you might have had, let's say this was x is 3, right? And let's say this is here, let's go with negative 2, okay? And maybe you had 3 different pieces to your graph, like maybe you had a some kind of graph that looked like a parabola on the left, and then here you ended up having, let's say, this, horizontal line. I don't know if you guys remember doing this, and then maybe this open circle and a line that way. And so you're like, oh my gosh, what is this? And what it is that for various x values, like we say, okay, when x is less than negative 2, we're going to have a quadratic. We're going to graph a piece of a quadratic. And then when x is between negative 2 and 3, we're going to graph this horizontal line. And then when x is greater than 3, we're going to graph this totally different line. And so really these are 3 separate equations with basically 3 separate domains, because domains are the x values that you are going to use for your graph in that section. So we're not going to ask you to graph these now, and if and when we do this year, we will definitely go over how to graph them. But when you're evaluating a piecewise function, what happens is that they give you a function f of x, and they basically say, okay, f of x uses this equation when x is less than 1, so when or less than 0. So when your domain is basically from negative infinity to 0, you're going to use this equation, not including 0. And then when x is greater than or equal to 0, you're going to use this equation. So this is basically telling you which equation to use to evaluate at which time. So let me do some, it'll kind of make more sense. So it says, what is the value of the function when x is negative 1? Well, first of all, when x is negative 1, which one of these does that mean? So if x is negative 1, it falls under this one, because then negative 1 is less than 0, and that's true, right? So in other words, since negative 1 is this category, this is the equation that we'll use to solve it. So the value of the function when x is -1 is just, I'm going to plug -1 into this equation, and I'm going to get 1 minus 1 equals 0. So when x is -1, y is 0. So 0 is the answer to this question. So the next one, what is the value of the function when x is 0? Well, again, which one does it work for here? Well, this one represents x equaling 0. And so then I have to use this equation here, or this expression, to find the value here. So I'm going to plug 0 in for x, and I get -1. So I know when x is 0, the value is -1. And then I go to the last one, and it says, what is the value of the function when x is 1? Well, again, x is 1 falls under the x is greater than or equal to 0 category, so I have to use this equation, x minus 1. So 1 minus 1, and 1 minus 1 is 0. So the value of the function when x is 1 is 0, or I could do 1, 0 like that, okay? And that's how I solve it. So really, the value of x is going to let me know which equation I need to do, okay? I need to use. So last type of question I think that we're going to face is, what happens when we want to know when the entire function equals 0? What values of x will make the entire function equal to 0? Well, this is just a basic solving a quadratic or solving a polynomial question. Remember that when a polynomial like that equals 0, we're basically finding the solutions, we're finding the roots, we're finding the x-intercepts, right? We kind of refer to the same thing for every single one. So the x-intercepts are always going to give you a y value or an output value or an f of x value of 0. So how do we figure that out? Well, what we're going to do is we're just going to replace the whole f of x with the number 0. So we do, okay, 0 minus 2x plus 10, right? How do I solve for this problem? Well, minus 10, negative 10 equals -2x, -2, -2, and we get that x equals 5. So guess what? When x is 5, the function has a value of 0, okay? And so that's how we solve these. So this was a linear, so we could just solve for x. This one's a quadratic, so we've got to do this one a little different. This is, in standard form, and we have to do what we've done many times. We have to factor this side, and that's going to be x minus 2 times x minus 3. So x equals 2 and x equals 3. So we have two solutions for this problem. So when x is 2, our output is 0. When x is 3, our output is 0. Again, you can always answer these as ordered pairs as well. So you can do 2, 0 and 3, 0, or you can just do x is 2 and x is 3. Again, when we come to the number 3, 0 equals x squared minus 16. We know this is a difference of squares, so this is x minus 4, x plus 4. And so we know, again, x equals 4 and x equals -4. So plus minus 4 is the answer here. When we come to this one, again, 0 equals x cubed minus 81x. We're going to factor out a GCF, and we're going to get x squared minus 81. We keep factoring x minus 9, x plus 9, and again, each factor gets set equal to 0. And so we get 3 solutions here. And again, it's very consistent. Remember we talked about it. If x is to the 3rd power, you should have 3 solutions. So when x is 0, when x is 9, or when x is -9, our entire function will equal 0. And again, you can write it like that, or you can write it as x is 0, y is 0, x is 9, y is 0, and x is -9, and y is 0. Again, your inputs are your x values, and your output in this case has to be 0. So understand that when we make the entire f of x equal to 0, that is not the same as saying what is the value of the function when x is 0, okay? That would be totally, totally different, okay? So that is something you want to make sure you keep organized in your, in your thoughts there. And then the second thing is the the way you write your answer. Just make sure that you put it in one notation or the other. I'm okay with either. And then let's just do this last question here that says basically the entire f of x equals 0. So we've got 5 minus 6x over 3. And so again, how do I solve this? Well, first of all, I can get rid of a denominator just by multiplying by 3 to both sides. So this is still going to be 0. And then my other side is going to become 5 minus 6x. Subtract 5, subtract 5. I get minus 5 equals minus 6x. Divide by minus 6. And x equals 5 over 6. So when x is 5/6, y, or the output, is 0. And then again, last one here, it says find where f of x equals g of x. So what we're trying to do is we're trying to figure out, okay, what is the value of that we can plug into this x here that's going to make this function here equal this function here? What x values will make that happen? Well, whenever we do that, remember what we're trying to find is where f of x equals g of x. So what we do is we're going to sub in the equation for f of x, and we're going to sub in the equation for g of x. And we're going to solve for x this way. So notice this is a quadratic. I'm going to add x squared to both sides. And I'm going to end up getting 2x squared plus 1 equals 3x. And then I'm going to subtract 3x from both sides. And I'm going to end up getting here 2x squared minus 3x plus 1 equals 0. And again, traditional factoring here, I have to have a product of 2, a sum of -3. So I know that's minus 2 minus 1. Since a is 2, I have to do the whole 2x squared minus 2x minus 1x plus 1 equals 0. GCF of the first one. GCF of the second one. This becomes my first GCF, and then 2x minus 1. So x equals 1, that's one solution, and 2x minus 1, so that's 2x equals 1, so x is a half. So these are the two values of x that will make the equation on the left equal the equation on the right, or that'll make f of x equal g of x, okay? And now I go to this last one. Again, remember I'm trying to figure out when f of x will equal g of x, which means when will x squared minus 1 equal negative x squared plus x plus 2. So first of all, right, I need to combine my like terms, and I see it's a quadratic, so I'm going to move everything over to the left. So I'm going to do plus x squared, I'm going to do minus 2, and I'm going to do minus x, right? So this cancels, this cancels, this cancels, and I'm going to get over here, I've got 2x squared minus x minus 3. And so again here, I've got a factor. So I have an a value other than 1, which you know how much I don't like that. But I'm going to get minus 3 plus 2, and I'm going to expand this out to 4 terms. So minus 3x plus 2x minus 3 is 0. GCF of the first two, 2x minus 3. GCF of the second two, so 2x minus 3. This becomes the GCF here. I pull out, and I'm left with x plus 1. So I get here 2x minus 3 is 0, 2x is 3, and x is 3 over 2. And x plus 1 is 0, so x is -1. So these are my two solutions for this problem. These are the two values that will make f of x equal to g of x.